So, properties of parallelograms. Your parallelogram is defined, so if you're doing like a proof and you want to use definition of parallelogram, it's a quadrilateral with both pair of opposite sides parallel. To prove something's a parallelogram, that's all you have to do, is you prove both sides of the lines are opposite, or I mean are parallel. How would you prove a line, two lines are parallel? They have the same slope, absolutely. So to prove that, you look and see if they have the same slope. Absolutely. Good job. Alrighty, then properties of the sides. Okay, on your parallelograms, both pair of opposite sides are parallel. So if we're looking at this picture here, that would mean that QR is parallel to which side? Perfect, Justin. PS. Absolutely. And that makes QP parallel to RS. Okay? That's what these symbols mean. Right? Okay, both pairs of opposite sides are also congruent. That's going to mean that QP is congruent to RS. And then we have QR is congruent to PS. Find another spot to sit here. All right, now properties of angles. All right, both pair of your opposite angles. What does it mean to be an opposite angle? If I have angle P, which one is going to be opposite? Angle R, because it's on the other side. So that means angle P is going to be congruent to angle R. And then, so I have that one congruent to that one. That means angle Q is going to be congruent to angle S. Okay. Consecutive angles. What's consecutive angles mean? What does it mean to be consecutive? Same side, next to each other. Okay, perfect. So that means that if they're supplementary, what's that mean? Justin, you're on fire. They equal 180. So that means that angle P plus angle S is going to be 180. You've got angle Q and angle R equaling 180. But you also have Q and P too. So angle Q plus angle P is going to be 180. And angle R plus angle S is going to be 180. Okay. All right. Last angle thing or property. Interior angle sum is 360 degrees. What does that mean? What does interior angle sum mean?
All the angles on the inside of the parallelogram add to 180.
Perfect, perfect, perfect. So angle P plus angle R plus angle Q plus angle S is going to equal 360 degrees. Okay? They don't have to be equal, but they're going to all add up to 360. Okay? All right, last property. Diagonals bisect each other. What does it mean to bisect? Cut in half, right. Okay, so that means that I have QS, and so T is where it bisects with PR, so that means QT is going to be congruent to TS, and PT is going to be congruent to TR. Okay? All right, let's use these properties and do some examples. All right, segment DG is going to be parallel to which one? EF, perfect. So to EF. All right, DE is going to be congruent to which one? GF, perfect. And GH is going to be congruent to which one? HE. Look at you guys. All right. Angle DEF. So that's going to be angle DEF. That's this angle here. It's going to be congruent to which angle? So we're going to do FGD. So FGD. Okay. EFG. So EFG. This angle here, angle F, is supplementary to which one? You actually have two choices. It could be supplementary to angle E. It also could be supplementary to which one? What other one? Angle G, because it has to be next to each other, right? Perfect. And triangle DGE is going to be congruent to which triangle? If we start at D, then we're going to have to start at F and then GE. How do we know that those angles or those triangles are going to be congruent? What theorem proves your triangle congruency? That you're in the right categories, congruent parts, but we know this side's congruent to this side, right? We know this side's congruent to that side, correct? And we know that side's going to be congruent to that side. So which theorem would it have been? Side, side, side theorem. Perfect. All right. Let's find the measure of the angles now. Okay? All right, measure of RST. So that's going to be RST, that's going to be this angle here. How are we going to go about finding that one out? Well, what is the angle of R? No, angle R is going to be all of this. So angle R is 55. Which angle is congruent to each other? R and T is congruent. So this one has to be 55. Would you agree with that? Okay. How much does the whole angle or all of the interior angles have to measure up to? Okay, so 360 minus 55 twice gives me what? So that would be 110, correct? So that would give me, what'd you say? 250.
Quick maths.
Proud of you. Okay, so if angle S, it has to be congruent to angle U, right? Okay, so that means if I divide 250 by the two angles, what's RST going to be?
25.
Equals 125. Good job. So now we can just go through. We already figured out all the angles, so STU is going to be 55. And then TUR is 125. Okay? All right, now find B. If this side, which side is it congruent to? ST. So I could say 4B minus 1 is equal to 23. You agree with that? Okay, so 4B is going to be 24. That makes B equal to 6.
No.
Okay?
No, where she got 6 from.
Because 24 divided by 4.
Okay, yeah.
All right. Good clarification. Thanks for asking. Okay. Now, basically, how would I want to set this up to solve for x? What do I know about these two sides? They're congruent. So if they're congruent, what does that mean? They're the same and they're equal. So I could say, hey, x plus 20 equals 3x minus 14. And then I can solve for x. So if I subtract x and add 14, I'm going to get 2x is equal to 34. And so x is equal to 17. Good? All right, do we need to do y? Let's do y on the angle. What I know these two angles are congruent, so I can say, hey, 2y minus 5 is equal to y plus 15. So if I subtract y and add 5, y is equal to 20. All right, last one, and then I'll turn you loose. What do I know about the diagonals? When they intersect, what does it create? No, it's not the. It does create a midpoint, but what does it tell you about the diagonals? What does it tell you right above? They bisect each other.
Oh, I already said that. That's
So,
the first thing I said.
okay, I didn't hear ya. So that makes 3x is equal to 4x minus 3. So if I subtract 4x, I'm going to get negative x equals negative 3. So what's that make x equal to? Good?